one of the best speakers, the best technical speaker, hands down, Mark Russinovich, is speaking in the other room. And still all of you are here. The room is packed. That shows you guys really care about keeping your secrets secure in the cloud. And for that, I and my team love you, really. Why? Because if we didn't care, this is what happens. You heard of the Uber breach recently? That was an exact replica of this particular pattern. There were some account keys up in GitHub. And frankly, it can happen to everybody. I mean, companies are so large that in a large company, one newbie somewhere makes an accidental mistake and brings down the entire company. And it just takes a lot of discipline to have defense in depth to make sure everybody is doing the right thing in a big, big company. It's not just security, it's outages. Microsoft has had its share of these. Sometimes we didn't renew our certificates in time and our site went down, and this is very common. If you are one of those companies that are subject to PCI, SOC, ISO, and these kinds of compliance standards, you know that you need to have a certain operating procedure, that you renew certificates at a certain time, you have so many administrators, and auditors come verify that you actually do what you say. And if you don't, you lose your compliance. There are findings. This is the worst of them. No matter how perfect you are, things go wrong. That's just inevitable. And the best thing you can do is to make sure that you can recover fast. There used to be a saying, mean time to failure in the past during manufacturing. Now in the cloud world, they say mean time to recovery, because failures do happen all the time. So I am Sumed. My team at Microsoft runs the PKI, key management, and secrets management and encryption product management team. And today I'll walk you through a fictitious company, Woodgrow Bank, and walk through the typical life cycle of how their cloud adoption starts and grows and grows and grows, and what the implications to secrets are, and what you can do at each stage to keep your secrets safe. So let's start with Carlos. Carlos is the app developer. Actually, let me just introduce you again. So Carlos is the app developer who's the first developer to actually touch Azure in Woodgrow Bank. Builds an app. Slowly, more and more application developers start building apps on Azure. At some point, the CISO's office says, crap, I need to get on top of this. There are 5,000 subscriptions in my company that are using Azure, and I need to make sure that nobody makes a mistake. So slowly, they become very mature. At some point, they have enough confidence in Azure that they're starting to migrate some of the critical applications, their payment applications, and Arti, the payments dev, starts thinking about migrating existing applications. And now this is the world of compliance and standards and legacy constraints and so on, and now you need more than just a key management solution in the cloud. You need HSMs with some specific characteristics to them. And so we'll walk through each of these stages to see what the right solution pattern is. So let's start with Carlos. Carlos is building a very simple application. There's a front end that is built on Azure Web Apps. There's a back end that's built on Azure Virtual Machines. The front end writes some data to an Azure storage blob. The back end reads from it, and once in a while tweets something on Twitter. Now, as he builds this application, one of the things Visual Studio does is it senses where it feels like, hey, that's a credential, perhaps. And if that's true, then you should not be embedding it in your code. You should be putting it somewhere else in a key management or secrets management solution. So that's a good hint. Now, thanks to Visual Studio or his own knowledge, he knows, hopefully, all of the secrets in his application. Even in this small application, there are a number of secrets. Where there's a VM, there's a password or an SSH key or something like that. In this case, let's just say it's a Windows VM, it's an admin user password. The back end and the front end need to talk to the storage account, so there is a storage API key. In Azure, that's a primary key, secondary key. Let's just call it an API key. The VMs need to tweet something to Twitter, so there's a Twitter API key. There's a TLS certificate on the front end. Well, anything that you store at rest better be encrypted. And now, if you want to encrypt that, there is an encryption master key on both of these. Wow, that just grew pretty fast. What do? Well, first rule of managing secrets is to not have secrets. in the last year, Azure introduced this concept called Managed Service Identity. This is a built-in feature of Azure Active Directory. So if you have an Azure subscription, you have Managed Service Identity. It's free. If you have an application in one of the Azure platforms, like virtual machines or app services or functions, and you're talking to an Azure service, you have a built-in identity that you can use to talk to some of these Azure services. It's not universal yet, but it's growing. Storage is one of those services that does support MSI on the incoming side. VMs and app services are those that support it on the outgoing side. So in this particular case, the storage API keys, you can get rid of them and use your MSI identity. You don't need to manage a credential. For those in the audience who are developers, that's roughly how it looks like. Your code in the VMs and the app services does a get on a local endpoint. No authentication required because it's running right there locally. And you specify the resource that you want to talk to, and it gives you a token. Azure manages the rest for you. It manages the credential in Active Directory. It rotates the credential and all of that. And you just get a very short-lived token that you can talk to it. All right, so that's great. You got rid of 2 of these. What about the rest? For the rest, we have Key Vault. Now, show of hands. Key Vault is which of these? Well, all of them. Well, so now there are some in the audience who have been using Key Vault for a while, but there always are a few who are new. So let me just quickly zip by what Key Vault is. Key Vault, as a secrets manager, looks like this. When you're provisioning a set of Azure resources, you can, up there is a human. As a human, you can say, well, I have this Twitter password. Let me just enter that into Key Vault and be done. Oh, sorry, I scrolled too fast. You can enter the Twitter password into Key Vault and be done. When you're provisioning Azure resources, the Azure Resource Manager will get API keys and such from those resources and put them in Key Vault if you specify that in your template. Your app, you can, at runtime, provision anything that you want. So we have apps at Microsoft, for instance, that do this every 4 hours. They just keep rotating passwords every 4 hours just to stay one step ahead, and they keep updating their secret in Key Vault. On the right side, once they're in Key Vault, you can distribute them to a number of places. There are some people who use it just as a manual tool, so 2 people in a team, 1 person adds something, their team member gets it out just for some testing. You can tell the Azure Resource Manager to say, well, that particular VM password over there that was in Key Vault, use that when creating a VM and set that as the admin password. So you can do that when creating VMs. You can do that when creating SQL servers. There are DevOps tools now that have direct integration into Key Vault, so you can specify in VSTS, now called Azure DevOps. That is the location to my Key Vault. Just pick up my secrets over there. So in your release tasks, you can just not have secrets over there and just pick them up dynamically. Services like Databricks at runtime can just read secret values from your Key Vault rather than have them encoded right there. And of course, your app at runtime can pick it up. The reason I highlight that in italics is that we think of secrets as dynamic entities, not static entities that are provisioned only when your app starts up. Even as your app runs, the values of your secrets need to keep changing. Like I said, some of our applications keep changing secrets every 4 hours. So your runtime needs to keep looking at Key Vault to say, hey, is there a new value for me? Is there a new value for me? And how does it do that? You remember the previous slide, MSI? So most of the Azure platforms like VMs, app services, and so on, you have a token that you can use to talk to Key Vault to retrieve the rest of the secrets. Certificates management. Same thing, humans can add certificates, but more powerful is the built-in CA support, where as a CA, you can configure Key Vault to talk to DigiCert, Global Sign, or Dtrust. You have to configure your account over there, and Key Vault will generate a key pair, generate a certificate service request, send it up to the CA, get the cert, and keep monitoring. If the cert is about to expire, go back and keep renewing. And so in your Key Vault, always you have a fresh certificate. Our partners like Venafi have built that out even more by integrating with things like an on-premises CA, ADCS or Entrust or EJBCA, or a variety of other CAs. And so that thing just keeps growing. The fan-in is pretty large. On the fan-out side, from Key Vault, once you have a certificate over there, a number of Azure services are built in to say, instead of provisioning a PFX or PEM file as by value, just provision it by reference. So you can configure web apps, VMs, functions, CDN, or API management to say, just pick up my certificate from that place. And they'll keep monitoring. VMs don't, but API management does, CDN does, and web apps does. They keep monitoring your Key Vault to say, is there a new certificate for me? So that way you don't have an outage. Key management. Either as a human or what's shown at the bottom is an HSM. You can provision keys into the Key Vault, and you can configure a number of services to say, when encrypting, instead of using your own keys, use my keys that I put in my Key Vault. And so that's called encryption with customer managed key. Now, this particular KMS is backed by HSMs behind the scenes. Those HSMs are FIPS level 2. There are certain characteristics of them that are level 3. Physical security, role service and authentication, EMI, EMC, and design assurance. Depending on your needs, this may or may not be sufficient. We'll look at further options down the slides. All right. Key Vault as a service is available in every Azure region. So when an Azure region goes live, you're guaranteed to have Key Vault over there. At this point, Azure is, I think, I lost count, something like 50 regions across the world. What's that? 54. Wow. Our folks know better than me. Every 2 weeks, there's a new region somewhere. In all of those regions, there are typically laws that our customers need to subscribe by. So we stay one step ahead of you and just pre-certify Key Vault for as many certifications as we can get our hands on. What's new for those of you using Key Vault in the last year? We have now new key lengths and algorithms. We introduced additional key lengths and RSA. We also introduced ECC, and especially SecP 256K1. Blockchain and IoT are the two hot things these days. For blockchain, SecP 256K1 is very important. From a security perspective, for a defense in depth, we added a feature called VNet Service Endpoint that allows you to lock down access not just to the people or apps that you specify, but coming from specific network IP addresses or specific virtual networks. We also have alerts now built in, so you can monitor for certain patterns and send SMS, email, and so on. We'll have a video of that. We have Azure Policy. We'll cover that. Monitoring. So now, for those of you who are maintaining live site, you can go to the Key Vault that you're using and say, hey, is there a problem in my app or is this particular Key Vault? And you can actually see, is my Key Vault up or down and what's been happening with failures and so on, right, built in there. You can now back up any object type. We used to have that for keys a couple of years ago, then we expanded it. Sorry. We expanded our ACL. This was a very common request. I need more people to be added to the Key Vault, and so now you can support up to 1024. We strongly recommend you don't actually have too many people in production. Normally that should be 0 apart from the app, but this is very useful in test scenarios where people are just testing and having a large number of people share the Key Vault. All right, now the services that are using Key Vault, there are some advancements there as well. Storage and SQL are now GA with their customer managed key feature. Disk encryption used to take a while to encrypt VM disks. Now we have the single pass encryption that's much faster. I talked about new services that support customer managed certificates and customer managed secrets as well. All right, let's get back to Carlos's application. Thanks for the patience for those of you who have been using Key Vault. So in Carlos's application, these secrets are still left. What do you do with them? Well, first add a Key Vault to your deployment. You provision either secrets. So in this case, a human being provisions number 2 and 3 on the left, which is your Twitter API key and your admin password. You configure Key Vault to talk to a CA to provision certificates and renew them automatically. Then you use an HSM to upload keys to your Key Vault for the purpose of your storage and disk encryption. Okay, so all of your secrets are in, and some of them will get auto-renewed all the time. On the right side, when you deploy your application, the Azure Resource Manager will say, hey, there's that VM password. Let me use that when spinning up the VM. So when your VM comes up, it knows the admin password. Right after it comes up, or as it comes up, it needs to decrypt. BitLocker needs a key for that. And so that the Azure host at that point reaches back to Key Vault and says, hey, get me the BitLocker key and let me decrypt the VM. After the VM comes up, the app starts running, and it needs the Twitter API key. So now your app using its managed service identity in the VM goes back to Key Vault and says, get me that Twitter API key to talk to Key Vault. Your storage account gets deployed. The storage account, anything that's put in there automatically is encrypted, but now you can specify a customer managed key, and it reaches out to Key Vault using the identity of each account to retrieve, to be able to decrypt or encrypt the storage account. And then finally, your web app, the web app framework itself, front-ends TLS for you, it reaches out to your Key Vault on your behalf to retrieve the certificate, and then uses that to front-end all HTTP traffic and then passes the traffic to your app. So now, these secrets of very diverse kinds are all provisioned, and you can manage them all in one place. And so that's important because all of these, despite the diversity, have some common characteristics. All right, so that leads on to best practices for managing your Key Vault. So far we've covered the basics of Carlos, just trying to get his app up and running, and so far it's functional. But well, now as he moves it to production, certain things start becoming important. Availability and disaster recovery come first. Well, security and availability, you can argue, but for availability, let's try to look at the risk model. As a company using Azure or using Azure Key Vault in particular, there are three broad risks. There are physical risks from the environment, lightning strikes, earthquake, maybe a particular disk goes bad, and so that's one set. The second set of risks, interestingly, comes from your own team. All of you probably have at some point been exposed to some insiders that were rogue or malicious, or just careless. Then there are risks on the Microsoft side. Maybe there's an attack on Microsoft at some point, and we have to think about all of these things to make sure that we do what we can do, and that we give you advice on what you can do to cover it up. So let's start with the physical. Well, Microsoft largely just covers these. We have really high redundancy in our HSMs, really high redundancy in our front ends, really high redundancy in our storage accounts. Everything you write is written to 3 copies where you write, plus 3 other copies in a remote region. And so that way, your data is never lost. If we find any indication of something going wrong, like recently we had a huge lightning strike in San Antonio, the first thing Microsoft does at that point is to preserve data. Preserving data is even more important than uptime of services. And we start shutting down data storage units in a sane manner to make sure that they never lose any data. And what happens at that point is we route the traffic to an alternate data unit, maybe running in the same region, maybe running in a remote region. Same with our front ends. If our compute front ends go down for whatever reason, or our HSMs go down, we have ample redundancy in the same region, but if the entire region goes down, we route it to a different region. So largely it's covered. Now there are always edge cases, and there are things that you can do on your side, but they are really complicated, and short of designing a distributed transaction controller, it's hard. So we generally recommend for this class of risks, just use whatever is built in. Now, let's talk about your team. Well, somebody may accidentally delete a Key Vault because they had some script that ran over all of your Key Vaults, and they thought they were all test, but, well, one of them was a production one or whatever. Well, there is a feature called soft delete. You must turn that on so that it acts like a garbage can. So when you delete something, it goes in a recycle bin in your subscription. You can always restore it back. It stays there for 90 days. If you don't touch it for 90 days, it just gets purged automatically. Now, beyond accidental delete, there may be an attack on your side. Maybe a ransomware attack like WannaCry last year. And maybe that got on your laptop, and you're logged in on your laptop, and it went into your subscription and just maliciously started deleting everything. Maybe it even retrieved some secrets and said, I'm going to stash them somewhere else and charge you for a ransom, whatever it is. So there are 2 things you can do for that. Number 1 is enable purge protection. So I talked about soft delete. Soft delete semantics are that I can delete something, it goes in a purge, it goes in a recycle bin. If I don't touch it for 90 days, it gets purged. However, in the 90 days, I can either restore it or force delete it. That force delete is called purge. If you have an attack, that's no use. It's going to go force delete it for you. Purge protection means you're waiving the right to say, I do not want to touch this for 90 days. So Azure will keep it for 90 days no matter what you do. That's your option to turn it on. You can also take backups and store them completely outside of Azure. They are encrypted backups of objects in Key Vault, and you can keep them wherever you want. You can restore them back into your subscription. There are other cases where it's not malicious, but you just really thought that you're done with this particular app. You deleted it all, and then something came. Maybe a legal request came your way and say, hey, I need that data again. Again, backups are useful to retrieve from cold storage. Now, let's talk about the Microsoft side. Maybe there's a bug in Microsoft code. Maybe there is an attack on Microsoft that's causing risk. Well, Microsoft itself does enough redundancy, some online, some offline, so that if there's an attack that spreads in the online copies, the offline is not impacted, and we can quickly restore and all that. Having said that, as the owner of secrets, obviously you are concerned. And there again, having backups is a great defense in depth. Let's talk about security. Now, the basic authentication mechanism in Key Vault is Azure Active Directory. As a user or app in Azure Active Directory, you go get a token. Your identity is specified in the permissions list in Key Vault. And if you are, then you have access. So that's a good start. However, passwords get hacked all the time. This is a real story. 2 months ago, one of our customers was consistently logging in from a particular IP address. And one day, he noticed that his user account was accessing his Key Vault from a Tor IP address. He had turned on logs, so he could see, hey, what is that IP address? I don't recognize that. Probably the password got leaked. Somewhere a credential got leaked, and it came from a different place. So immediately he revoked permissions, changed his password, reset. Things were good. But clearly, you need defense in depth. Now, because Azure Active Directory is the basis for authentication, you automatically inherit a bunch of authentication best practices right there. The chief of them is MFA. Please turn on MFA for all user access. Now, MFA is great for users. What do you do for services? Services don't have a second factor cell phone on which they can type in a number. So for that, I just introduced the concept of managed service identity earlier. In that case, your service doesn't actually use a credential. So if your service gets hacked, the best it can do is get a token for 1 hour. It can't actually get the long-living credential to use outside. Now, for both users and services, as an additional defense in depth, is VNet Service Endpoint, and we'll talk about that shortly. This locks down access to particular virtual networks or IP addresses, so that way, even if your credential gets leaked and your second factor gets leaked, there's a network layer to make sure that their access is secure. Now let's talk about authorization. Now authorization, there's an access control list on your Key Vault, and that's a good start. However, some of you, maybe not all of you, probably use security groups for a variety of other access management, have security group management software. One of the good practices that you can use is to try to do 2 things. Never really have a user having a standing access to your Key Vault. Generally, users only need to do actions once in a while, and they shouldn't be on your Key Vault at all. But more importantly, even if they do, add them via security groups. And through your management software, you can make sure that access is limited to whatever, 1 day, 3 months, whatever your policy might be. So inside Microsoft, as an example, every security group has to be created and managed through a particular software that keeps checking once in a while and checks with your manager. That person has been in the security group for so many days, still required, and that way, if you change teams, at some point your access gets cut off automatically. I'll skip over that. That's an advanced concept where actually app plus user is an interesting concept. So there is the idea that there are some applications that behave on behalf of, that access Key Vault on behalf of users. There's an interesting hidden concept that we have not documented much, which is the app can get a token on behalf of the user and get a compound token. So that way you can, on your ACL in Key Vault, you specify the caller must be both the app and the user at the same time. So if the user comes separately, no access. If the app comes separately by itself, no access. Both of them have to be there, and only then they have access. Interesting concept, supported directly by Azure Active Directory. All right, monitoring. Enabling logging is the first step, and now we added alerts. I showed a video of that. And then reports via log analytics. Other best practices. So security boundaries per app. So some of you have lots and lots of key vaults. Our guidance is generally one app in Azure is one resource group. Everything in that app, try to keep as local as possible. So if you're creating your app in, let's say, West Europe, your key vault must be in West Europe. If you're creating a highly available app where one slice of the app is in West Europe and the other slice of that is maybe Singapore, then keep a key vault in West Europe and keep a key vault in Singapore. Every app ideally should use a different key vault because access is at the key vault level. So having multiple apps secrets in the same key vault is a dangerous pattern. One app gets hacked, all of your secrets go away. So always separated. Key vaults are free, so you can create any number of these. The other good practice is separating ownership between apps and your key vaults. So let's consider the case of a SQL database. Typically, the DBA and the key owner, in many cases, people use one and the same person, but they don't have to be. You could have a separate key owner that keeps tabs on what the DBA is doing. So that way, if the key owner says, well, there's something fishy going on in that department, I'm going to revoke that particular SQL server's permission. The DBA really can't do anything. So that's another good practice. All right. Let me dive deep into this new feature that we just talked about, the VNet service endpoint. The gist of it is as follows. Now here you have the front end, a storage account, and a back end, and then you added a key vault. That gray thing is your virtual network. So typically, you would put all your resources in a virtual network, and that could include your humans because you can extend that virtual network to your on-premises and come in from inside the virtual network. If you turn on VNet service endpoints on your key vault, you specify a VNet ID and optionally a subnet ID. Either you could do that or you could specify specific IP addresses. Now, let's say you go with the former. You specify VNet ID and subnet ID. That person over there on the left needs to be not just authorized on the key vault, but also needs to be inside that virtual network. Ditto with the front-end app and the back-end app. So all of those get access. But if you're outside, even if you're legitimate, you don't get access. Now, there is one special case over here, this particular storage account. You can add your apps to a VNet, but what do you do for PaaS services like storage? They don't run inside your virtual network, and you still need to turn on encryption with customer managed key on that one. So what do you do there? So there's a checkbox there that when you configure virtual networks service endpoint on Key Vault to allow trusted services. So there's a hard-coded list of trusted platform Azure services. You can optionally say, yes, I want them to be able to access my Key Vault as well, and then that particular Key Vault can be accessed by anybody from the virtual network or that list of services. Now, if you're running inside virtual network, some of these applications have to punch a hole through the firewall to be able to reach out to your Key Vault also. So that's the converse problem. Not a security, but a management nightmare, because now if you're accessing lots of Key Vaults, you don't want to go back to your admin and say this IP address, that IP address, and so on. So the thing that makes it convenient over there is something called service tag, where you're on your firewall in Azure, you can specify a Key Vault service tag, and it automatically translates that into the set of IP addresses that correspond to Key Vault, and firewall management becomes simpler. All right, so let me play a video with that. All right, so here in this particular virtual network, this WB VNet Singapore is a virtual network. I have a storage account called WB Encrypted Storage. Now, just to show you how I'm using Key Vault in this case, I have turned on encryption, and I have specified a particular Key Vault URI, and that's where my master key lives. Okay? Now, let me go back to the virtual network. in this virtual network lives the key vault also. Now, if I go to the keys section and try to list the keys, I can see that there is a key, and this is the one that I have been using for storage. So far, I have not turned on VNet service endpoint. I can list these keys from anywhere. I'm logged in from some random place. Now, let me turn on virtual networks service endpoint. The first thing, I go to this pane, and I say, well, add one of my virtual networks. So I select the one that I want. Next thing is optionally select a specific subnet within that virtual network. Okay. Now, this is the first time I'm doing that. I enable it. Once that's done, I click one more. And just wait for the changes to propagate. Now, this is the trusted services point. I need the storage account to also access my key vault, not just my own services. So this is a hard-coded list of Microsoft services in that bucket, and I have opted to say I want them to be able to access also. So now those changes are getting saved to my key vault. It takes typically a few minutes to save. Now, if I go back to the portal and try to list keys, it says, sorry, you're unauthorized because you're logged in from outside the virtual network. I am the owner of the key vault, and I just lost access. But now let's go to a virtual machine and try to see if I can access my key vault from there. Now, this particular virtual machine is running inside the virtual network. So I list my key vaults. I find this particular key vault. I try to list keys from within that key vault. And there you go. I can see my keys from inside my virtual machine, which is inside the VNet. So that's a quick flyby of that demo. Next feature I talked about was alerts as a defense in depth. So things go wrong. You may have forgotten a particular security control. How do you watch out for bad patterns? So there are two things. Number one, in Key Vault itself, if you go to the portal, now there's a built-in UI to set certain alerts. That's the simplistic way. There are some canned patterns over there that you can pick and say, I want my alerts to go to this particular SMS phone number, call me or SMS me. You can trigger it to go to Azure Functions and so on. If you want even more advanced, where, for instance, maybe you're a CISO trying to manage a bunch of key vaults together and want to set a common condition across all of them. Maybe you want to go look at the cross pattern between your key vault and your app, saying that particular app's logs show that access did not happen in this window, and still I'm seeing some access on the key vault. So doing all these cross things, log analytics is the more advanced flow for that one. So there is built-in alerts blade for the simple things, and then there is log analytics for the more advanced things. I'll show you a demo of the first simple flow. So in this particular subscription, I have a key vault called Kiwi Ignite 501. Okay? I want to be able to set alerts on that. So I went down there, clicked on alerts. I don't have any alerts at this point, so it's blank. I create a new rule. So the first thing it says, wait, which parts did you want to monitor? So I select a particular key vault over here. The next thing it asks is, what do you want to monitor about it? So now I say, well, I want to be able to monitor anybody who writes to my key vault from the control plane, from the Azure Resource Manager, because that's how, for instance, permissions get set. The third thing it says is, okay, just type a name for this alert. So I type some name, some description for myself. It can take a few minutes for this alert to actually go into effect. The final thing it says, where do you want this alert to go? Now here, I can select not one, but multiple destinations. So I type a name for each destination, my friendly name for each destination. And then I specify what kind of destination is that. So I can say, I want an SMS for this kind of alert. So I say, if anybody writes from the admin side, then I want an SMS message to go to a particular phone number. Hit OK. And I create my alert rule. Now, in this particular case, I set an alert on writes from the control plane, from the Azure Resource Manager. Why? That is the most dangerous kind of write you can have, because from the Azure Resource Manager, you can actually change permissions. So in this particular case, let's say that somebody, owner, logged into the portal and added somebody called James Bond. The name sounds evil, but added him to the permissions list on my Key Vault. That's dangerous. Who's James Bond? And why is this guy adding some random person? Well, the addition went through successfully, but what happened next is that phone number that you had specified got a text message immediately, within 5 minutes. It says, hey, there was a write by so-and-so person. In fact, what we did in the demo was the first write failed for some reason, the second write succeeded, and we got 2 texts. So it shows both of the texts over here. So every attempt, there is a text that shows up over here. So this is a way you can keep a second eye. Apart from all of the preventive controls, you can have a detective control to make sure that your key vaults are monitored safely. All right, so we started with Woodgrove Bank, with Carlos building a simple application. We shared certain best practices that Carlos can do to secure just his application's key vaults. That's a good start. Over time, the company grows. More and more applications start using Azure. More and more key vaults get created inside the company. And very quickly, there is just a large sprawl. Now the CSO goes like, wow, how do I get access? How do I manage all of these? Now, simple things would be, well, what if the CSO actually had access to all of the subscriptions, then the CSO would be able to do what each user can do. But that's a very bad pattern, because guess what? A CSO must not be an admin on all of the subscriptions, because that's just too much privilege. So how can the CSO do very specific actions on each key vault without actually being an admin? And that's what we'll go through next. All right, so this is Woodgrove Bank's subscription sprawl. At the bottom, I'm just showing, actually, let's just go top down. So there's Woodgrove Bank, and it has 3 different divisions: a wealth management division, a credit card services division, and a test division. It has lots of subscriptions. Each of them has resource groups, and each of them has key vaults. Now, your primary primitives for managing them, first of all, Azure Active Directory, natural primitive. Second is Azure Policy. It allows you 3 types of policies: audit, enforce, and remediate. The third one is Azure Log Analytics, and that you can use to monitor. Now, besides these built-in ones, other people have built external tools. Azure itself has Azure Backup to be able to back up key vaults. And then there are partners like Thales that have built a Cypher Cloud key manager that actually lets you monitor all these key vaults. Now, let's dig into that Azure policy. What does that mean? Now, audit means you can actually set a policy that says something like, let me check which of my key vaults, let's say this Woodgrove Bank spans France and Singapore, and it wants to make sure that all of the key vaults its members create are in France. So you set an audit policy to say, are there any key vaults in my entire organization that are not in France? It'll show you a list that says, here are all the key vaults. You did not need to be admin. It just shows you, here are all the key vaults outside. Enforce means next time somebody tries to create a key vault, that policy gets enforced and says, nope, you cannot create that key vault because that's not in France. So you're stopped right then and there. Remediate means if something is not compliant, please trigger this particular action to correct it. I'm going to show you a video of 2 things. The first one is a enforce pattern. Here, what I'm trying to enforce is every key vault that gets created from this point onwards in my bank must have soft delete turned on. Why soft delete? Because like we said, people make accidents and you want to protect the organization. So in this case, I go to the policy tab in Azure as a CISO. I go to deny if soft delete is not enabled. Now this particular policy is authored. there is an entire talk on Azure policy, so I won't go into the details of how Azure policy works, but it's a bunch of rules that say if the vault does not meet this particular pattern, then do X. And so in this particular case, I set that policy everywhere. Now some person is trying to create a key vault that's not in that specified, that's in the specified region, but it doesn't have soft delete turned on. Immediately, there is an error. It says, sorry, you cannot create this key vault because it fails the policy. Now, apart from failing this new create, it also did one other thing. Next time, if I don't have it here, but if I wanted to be able to see what are all the key vaults in my organization that don't have soft delete enabled, you can also go there and actually check. So in the interest of time, actually, I'll skip that, but you can actually go to the policy tab and see here are all the key vaults where soft delete is not enabled. Let me talk about one other thing. This is a remediate policy. So let's say I'm a CISO who says, I want to be able to monitor every single key vault that's in my organization. I want to get those logs. I want to be able to set alerts on those logs. This policy, enable diagnostics, does that for you. So it looks at every single key vault and says, is logging turned on? If logging is not turned on, then the remediation action is turn it on and route those logs to a particular log analytics workspace. So I go to assignments, click that enable diagnostics, and turn that on. And this particular policy is saying for all keywords that are located in France, send the debug logs to a log analytics workspace located right here. Now, when I run that, I can see it immediately starts triggering when I hit that remediate button over there at the bottom. And that policy is running right now. And if I look at the details of that policy, I can see there is a bunch of key vaults where it's actually processing each of them. Are you in France? If so, then turn on logs. And all of these logs will now get routed to a common log analytics workspace. So CISO did not have to be an admin on the keywords themselves, but they still got it all. So again, Azure Active Directory and Azure and policy as a whole is a framework to let you manage all of your subscriptions without necessarily having to be admins on every single one of them. And it just automatically happens. All right. Now, we talked about secrets and key management. Let's talk about Aarti, the payments dev. Now, Aarti is building an application that is maybe subject to IDaaS compliance. Or maybe there is some PKI involved at the back end that's subject to web trust compliance. And now you get into the world of FIPS level 3 and common criteria, or maybe you have some existing keys that you need to migrate. So we have a new service for that coming up soon. The new service is called Azure Dedicated HSM. What is it? It's HSMs that are directly exposed to you, so you have the full power of the HSM at your disposal. They're FIPS level 3 and common criteria EAL4, so you can do IDaaS, for instance. You manage the HSMs directly. These HSMs are Gemalto Luna 7. This is the latest breed. These are really fast appliances. We have the Gemalto folks right here if you have any questions about those appliances. Very, very low latency and very fast. How does it work? Well, you go to Microsoft, to the Azure portal, and you request an HSM. Microsoft hosts the HSMs, powers them up. You specify the virtual network to which to connect to. We will connect it to your virtual network, so you access it from your internal IP address. From that point onwards, you control everything else. You control the root keys on that. Because it's everything else, and because Microsoft at that point doesn't have access to the HSM, you must manage the firmware and patches and the availability and all of that also along with that. Now, you might be asking, wait, why did we have two services? Key Vault has HSMs. Why are we doing this? Well, each approach has its pros and cons, and that's why we have two of them, because one size does not fit all. When is dedicated HSM appropriate? Well, you need FIPS level 3, you need common criteria EL4, use dedicated. Well, you have a legacy application, and you're just migrating lock, stock, and barrel. It's been using Gemalto HSMs in the past, and you're just migrating as is. That's another good use case. Third use case is maybe you have a PKI that speaks PKCS11, or maybe JCE, or CAPI, and you just want to migrate it as is, and you cannot change it to talk to the Key Vault protocol. Well, that's another good use case for why you can just migrate the app to an Azure VM and connect it to a dedicated HSM. So this gives you close compatibility with what you have on premises. When is Key Vault the right thing to use? Well, if you're using a PaaS or SaaS services in Azure, like storage or SQL DB or disk encryption, the customer managed key, customer managed certificate, they have a strict requirement for Key Vault, because now a cloud service is trying to reach out to your keys have to be accessible to them, and Key Vault is the place that is accessible to all of them. A third set of use cases could work with both. Now, if you want cloud benefits, like ability to spin up something instantly, scale out, then Key Vault is the way to go. But if you are familiar with Gemalto HSMs and you want to use that, that's the other option over there also. Okay, now this is a quick overview of the HSM itself. This is nothing specific to Azure. Just wanted to call out a few things over here. These are the latest Luna 7 HSMs, blazingly fast. For a big enterprise, there are 100 partitions. More than 400 applications already integrated with this HSM model. The certifications already cover what many jurisdictions around the world need, and so that actually gives you a head start over there. And lots and lots, more than 80% of the banks actually already use it. So great initial dedicated HSM. All right, what are the next steps on this one? This service is not live. I mean, it's live, but it's in private testing. The general availability is coming soon, within the next few months. Supply will be limited. Each HSM takes up a fair amount of space, and so we'll have limited availability. Customers will be prioritized based on the revenue commit to Azure. If you have questions, if you need one of these, please reach out to your Microsoft account team, and we'll be happy to share details of the next steps. So again, we walked through a simple app developer building a first application, grew to what does a CSO do to manage lots of services across Azure and lots of Key Vaults for them. We grew to the more advanced use cases that have regulatory or backward compatibility concerns. There are some related sessions, like if you want to talk about customer managed key, then these are some sessions over there. The call to action. If you have secrets, first check if you really need them. Use managed service identity if you can. If you, for everything else, Key Vault is the way to go. We talked about a few security and availability best practices. We also have pages on them on our documentation, so please use those to be able to have the best design patterns for your Key Vaults. And finally, if you need dedicated HSMs, please do reach out to your account teams or to Microsoft support, and then we'll take it from there. Here are the resources. I'll be around here for any questions that you may have. Happy to take any particular deep dives. And again, for the HSMs, we have Alan and Alex from Gemalto right here. So if you have questions about the HSMs themselves, they are the people to go to. Thank you all.